have discussed experiments, differences in differences estimators. Today we are going to discuss quasi-experiments and regression discontinuity designs. And what we'll discuss in this, we'll discuss what are quasi-experiments, examples of quasi-experiments and differences in differences estimators, and regression discontinuity designs. There are two types of regression discontinuity designs, sharp and fuzzy regression discontinuity designs. We shall use simulated data for these sharp and fuzzy discontinuity designs using R, and our next video will be on minimum legal drinking age data. So in quasi experiments, these are also called natural experiments. These are different from the other experiments where you have one control group and other is treatment group. The one which receives vaccination is treatment group, and one which receives placebo neutral injection, that is your control group. But here in many cases you don't have this possibility. It's not ethical. So randomness is introduced by some variation due to some individual circumstances. These circumstances may be due to vagaries in legal institutions, location, timing of policy, or program implementation, natural randomness such as birth dates, rainfall, or some other factors that are unrelated to the causal effect under study. So in quasi-experiments, it is assumed as if some natural phenomena has occurred, and now you can compare where that natural phenomena is affecting and where it's not, or before, after, differences in differences. Two types of quasi-experiments. One is where your basically a treatment is completely at random, is completely determined as random. The other one is where it's partially determined as if random. So in first case we use OLS, in second case we use instrumental variables 2SLS. Examples of quasi-experiments. In this first example of quasi-experiments, the treatment is as if randomly determined. Does immigration reduces wages? Economic theory suggests that as wages increases, labor supply increase. However, if all else equal, immigrants will be attracted to cities with high demand, so OLS estimate of effect on wages of immigration are biased. So you cannot have randomized control experiment in this case, that you distribute immigrants to one city and others to another city, another to another city to carry out this experiment. Neither it is physical nor it is ethical. So there was a natural experiment which Card in 1990 studied that there was relaxation on Cuba population for immigration to US. Half of that population settled in Miami and half in other cities. What Card did, Card took data in 1979 from Miami and from Los Angeles, Miami 1981 and 1981 from Los Angeles, and then he used differences in differences estimators and found that there was not much effect of immigration on wages. Another experiment was from New Jersey and Pennsylvania city, that one state has increased wages, another state has not increased wages, and it was found that in general wage increase does not affect your labor demand. Effects on civilian earnings of military service. Does serving in the military improve your prospects on the labor market? So is it the case, or is it military trainings, or is it that those who join military service as officers or they are already smarter than others? So again, this example was completely as if random. Here these two are partially as if random. So you can estimate it by differences in differences. This one was in Vietnam War. There was lottery method. that if my name is included to serve in military, I have to serve, but again I have to fulfill some you see physical criteria to be part of military service. So then that lottery method determines partially as if random, so you may use 2SLS or that. I have given this example time and again in instrumental variable chapter and in previous videos of this chapter on experiments, distance to cardiac catheterization hospitals. So no, as we see that there is endogeneity. How this endogeneity was addressed? You have basically distance to cardiac catheterization hospital as if random. So similarly, there you see there are many other examples of quasi-experiments in the field of economics, and these are very useful for social policies. Basically, quasi-experiments provide a bridge between observational data sets and truly randomized control experiments. Then comes the regression discontinuity designs is an example of quasi-experiments. What are regression discontinuity designs? Basically, it's a statistical approach that utilizes threshold-based decision. I'll explain in the next slide. Making to estimate causal estimates of different interventions. Below a threshold, above a threshold, and then you compare those. Regression discontinuity is simple to implement, transparent, and provides real-world effects of treatments and policies, particularly where you cannot have random experiments at your own. Graphical presentation and statistical analysis of data developed by psychologists but later on used in education and labor economics. There is frequent use of threshold-based decision making, but regression discontinuity is underutilized. What is regression discontinuity design? Let's see. So there are two types of regression discontinuity designs: sharp designs and fuzzy designs. In sharp designs, you have very clear threshold, and below a threshold, you will either get you cannot basically this cannot overlap. This cannot overlap. If your CGPA is less than 2.02, you have to take summer course, and if it is 2.201, you may not have to take summer course. Similarly, if your income level is below a certain threshold, you'll get assistance. If it is above a certain threshold, you'll not get it. Fuzzy designs, basically there is some crossover. Some may who should be in the income support level, they get over, and those who are above that, they may get this. So basically probability of getting treatment may be slightly different for a slight overlapping region. So the approach is non-parametric. Parametric, we are not going here. Look here, I am going to discuss sharp designs. So here you have the simulated data. We have this simulated data, and so below this W0 threshold value, you are in one group, and above a certain threshold value, you are in another group. Whether you have to take summer course or whether you have to take scholarship, you are eligible for free lunch or not, you are eligible for free income or not. So this one is your sharp design. There is a sharp cutoff at below 0, greater than 0. This is by ggplot2, and similarly you can use model regression discontinuity design model RDD. You see regression linear model, and you have data and slope, same slope, and then you can see that there is a difference of 10 units between those who receive the treatment, who don't receive the treatment, and you have fitted this line. These are sharp regression designs. Now you have fuzzy designs. In fuzzy designs, your cutoff point is not exactly 0 and 1. You have some treatment probability which may vary slightly. for one group to another. Look here, you have basically here some blue points which are overlapping. So you may say that some students whose CGPA is greater than 2.2, they will not take not take this summer course, but some who have less than that they have to take, or there can be some who have less than that can skip, and some who have more than 2.2 they can take it. I have taken these commands from this Introduction to Econometrics with R. Stock and Watson book. So you can click here and you can get all this stuff from there. Thank you for watching. Take care. My next video will be on minimum legal drinking age effect using Stata and using R. Take care.